Oh, what's that?
Well, it's the chemical element fluorine.
What's fluorine?
It's an element on the periodic table.
What's the periodic table?
Yeah, let's take a closer look.
So what are those green things?
The green particles on the outsides are the electrons. They are negatively charged particles that form the electron clouds. As you see, fluorine has two electron clouds, the one in the inside and the one on the outside.
Oh, so what's that blob in the center?
It's the nucleus, formed by the blue particles, which are the neutrons, and they have a neutral charge. And also the yellow particles, which are the protons, and they're the positively charged.
Oh, so there's 9 of each, right?
Yes, as you can see, on the top left corner, the fluorine symbol, F, and the 9, which means it's in the ninth element of the periodic table.
What's that 1.6 thing in the bottom corner?
1.696 grams per liter at 0 degrees. It's the density of fluorine, of course.
Oh. Oh, so is that yellow thing fluorine at the top?
Oh, yes, this is the group of fluorine. Group 17, the halogens, of course.
Oh, so the others are the other things in the group, right?
Yeah. Acetine, iodine, bromine, and chlorine are very similar to fluorine, and that's why they're grouped in the similar group. They all have 7 valence electrons in their outer shell, and are prepared to take one more electrons to form a perfect bond.
What else are the similarities?
Well, if you have a hydrogen atom and you combine them with either any of the elements on that group, you form an acid, and the lower the number, the more reactive the acid is going to be.
So are any of them reactive on its own?
Well, they're quite stable since they only need one more electron to form the bond. So they can only bond with either group 1, the alkaline metals, or the transition metals that have one electron to lose while it's bonding. Speaking of bonding, this is an possible ionic bond formed by fluorine atoms and a calcium atom.
So calcium is Ca, right?
Yeah.
How does this circle thing work?
Okay, so the dots on the outside represent each element's valence electrons, which is the electrons in the outer shell. Fluorine has 7 of them. So calcium has 2. So that means it cannot bond with one fluorine atom because there will still be one left out by the calcium. So if they have 2 fluorines and they bond, so to speak, on each side of calcium, they will form an octet, which, as you can see on the fluorine, is 8 electrons to form a perfect stability situation.
Oh, so it looks like the calcium is giving away the electrons, right?
Well, this is more of the sharing type of bonding. But you can't say it's giving away. That means fluorine has 8 electrons. And each fluorine has 8 electrons. They're perfectly stable and will not react with anything else.
Oh, that's really cool.
Well, as you see, there are a lot of uses for fluorine nowadays in the modern time.
Oh, what are they?
Well, they're used for toothpaste as a cleaning agent for your teeth, or they're used in refrigeration gas to keep the refrigerator cool, of course. And they're also used as rocket fuel in a combustion engine.
Oh, was that planned?
What? No. Well, that's about it for me. I think my job is done.
Oh, that's really cool.
Okay, see you tomorrow, and I hope it's not Thanksgiving.
Wait, no. You need to tell me about calcium.
Bye. Weird.